Now let's learn about integral powers. What if I have a to the power n, or I have some powers to my matrices, or I'm multiplying the same matrix again and again? How can I write it down? So a square can be written down as a into a. Let's say if I have a square, so how can I write it down? Let's say my a matrix is a b c d, so I can simply multiply it twice, a b and c d. So whatever answer I get, that would become my resultant, which is my a square. And a cube can be written as a square into a, can be written as a into a square. Sorry, a into a square wouldn't be. This is how we can write it down. Now when we come into the properties of integral powers, again, a to the power m, a to the power n, the same properties that we use for integers, the power properties of integers, those are again same here for matrices as well. It would become a to the power m plus n. If we have am whole to the power n, it would become a to the power m into n. As I mentioned earlier, identity matrix to the power n would give us identity matrix only. So this is equal to I square, this is equal to I cube. So doesn't matter. If I matrix is multiplied by itself, it will always be I. And if any other matrix, let's say a square is multiplied by I, this would give me a square only. So you must remember this as well. And a to the power 0, I hope you all remember, for integers, anything to the power 0 is 1. However, for matrix to the power 0 gives us identity matrix. So identity matrix is basically the number 1 of matrix. So you must remember this thing.
So now let's look at this question. Here what has been given to us, A is equals to cos theta minus sin theta, cos theta. Then the matrix A to the power minus 50 when theta is equals to pi by 12 is equal to. Now whenever you have been given a question which is related to matrices and the power of such questions, let's say, given to you is more than a number which you can manually calculate, then in such questions what are you supposed to do? You're supposed to find out some type of pattern that the powers are basically trying to follow, and based on that pattern you would be able to solve whatever high power questions has been given to you. So from this question, what we can see is that a has been given to us. So first what we'll do, we'll try to find out a square. We'll see what are the values of a square that we are getting. Then based on that, we'll either try to find a cube or a to the power 4. And we'll see if there is certain pattern being followed in all these powers. If we find out a pattern, then we would be able to write down the power of a to the power n as well. We would be able to write that value as well, and based on that we'll simply substitute our n as minus 50 and we'll find out our answer. So first, since this is our a, which is cos theta minus sin theta upon sin theta cos theta, so I'll try to find a square first. So what would be a square? It would be cos theta minus sin theta cos theta. So I'll multiply this once again. This would multiply with a itself, cos theta. So upon multiplying this, what am I going to get? This would become cos square theta. Basically, this would become cos square theta minus sin square theta. So what is cos square theta minus sin square theta? Cos of 2 theta. So this would become cos 2 theta. What would I have below this? Sin theta cos theta plus cos theta sin theta basically becomes sine of 2 theta. Similarly here, if I take minus common, I would have minus sine 2 theta, and below I would have um, minus sine square theta plus minus cos square theta. So if I take minus to be common, I can have cos square theta, sorry, sine square theta minus cos square theta. So basically, simply it can be written as cos of 2 theta again. So I'm getting my a square to be this. Now let me find out my a to the power 4 as well. Based on that, I would be able to make any informed decisions that I have. So if I try to find a to the power 4, what would it become? Cos of 2 theta sine of 2 theta multiplied by minus sine 2 theta cos of 2 theta into cos of 2 theta sine 2 theta minus sine 2 theta cos of 2 theta. Now, if I try to find out this multiplication, what am I going to get? Cos squared 2 theta minus sin squared 2 theta in the first place. So I would basically have cos of 4 theta basically here. Since I have 2 theta in my extended function, so I would simply get transformed into cos of 4 theta. Similarly, here I would have sine of 4 theta. I would have minus of sine 4 theta here, and I would have cos of 4 theta here. So now if you look at all these three values, a square and a to the power 4, what is the pattern that I can see? If you see that in a to the power 1, I have cos of 1 theta minus sine 1 theta, sine 1 theta and cos of 1 theta. When I have a square, I have cos 2 theta minus sine 2 theta, sine 2 theta, cos 2 theta. When I have a to the power 4, I have cos of 4 theta minus sine 4 theta. So basically, if you look at all these three values, I have my basic structure of the matrix to be same. The only thing that is changing is the theta which is inside. When I had 1, it was basically 1 theta. When I had 2 as the power, it was 2 theta. When I had 4 as the power, it became 4 theta. So what is the pattern that I am looking at here? If I try to write down a to the power n, so this would basically become cos of n theta minus sine of n theta, sine of n theta, and here cos of n theta. So this is the pattern that I'm getting based on solving two or three multiplications. Instead of a to the power 4, you could have also found out a cube as well. For a cube, you would have gotten cos 3 theta minus sine 3 theta, sine 3 theta, cos 3 theta. So there you could have found out, spotted your pattern as well there. So since we know that a to the power n is this, and we need to find out a to the power minus 50, so I'll simply just substitute the value of n as minus 50. Let's see what we get from there. Minus 50 theta minus sine of minus 50 theta. Here we have sine of minus 50 theta, and here we would have cos of minus 50 theta. So we've gotten our a to the power minus 50. Now what we can do is we can use a few of our trigonometric identities here. What would be the first identity? That sine of minus theta is basically minus sine theta, and cos of minus theta is nothing but cos theta. We had studied this in trigonometric functions. So we can replace these values with that. So we would get a to the power minus 50 as cos of 50 theta sine of 50 theta. Here we would have minus of sine of 50 theta, and here we would have cos of 50 theta. Now let us try to simplify this 50 theta after putting the value of theta as pi by 12, because this is what we have to use as theta. So if I use theta as pi by 12, so basically what would be my value inside any of it? It would become 50 into pi by 12, which is nothing but 25 pi by 6. This is how I can write it down. Now let me try and convert this in either 2 pi plus something format, or 4 pi plus something format, or 6 pi plus something format, or pi plus something format, so that I can basically use them and convert my value of theta which is inside into some value which can lie in the first quadrant, so that it would become very easy for me to solve. So 25 pi by 12, pi by 6. How can you write it down? It can be written as 4 pi plus pi by 6. I hope you all can see this directly. This would simply become 4 pi plus pi by 6. Now what if I replace this value in each and every sine and cos? So basically I would have cos of 4 pi plus pi by 6. Cos of 50 theta would be replaced as this. So this would become cos of pi by 6. And what is the value of cos of pi by 6? Nothing but root 3 by 2. Similarly, I'll find out the value of sine of 4 pi by 6, 4 pi plus pi by 6. What would I get from here? Sine of pi by 6. And what is sine of pi by 6? Nothing but 1 by 2. So basically, if I replace all these values now in my final matrix, what am I getting a to the power minus 50 to be? This would become root 3 by 2 minus half root 3 by 2. So this is what I'm getting as my a to the power minus 50, and this is my answer. So keep this thing in mind. Generally, whenever you are given questions related to higher powers and you have trigonometric functions inside, logarithmic functions inside, or exponential functions inside, what you do is you simply try to find out a square, a cube, or a to the power 4 and try to identify certain pattern that they are following. Once you identify the pattern, you can write down your power for n as well. And once you can write down your nth term, then of course it is very easy for you to find out whatever power the question is asking you. So solve such questions in this manner. Now let's look at this question. A is given to us. Now when you closely look at A that has been given to us, you can see 1, 1, 1, minus 1 and 0. So basically this is a combination of 1, 1, 1. What does this simplify? This is basically our I. What is our I? 1, 1, 1, 0, 0, 0, 0, 0, 0. So basically you can see that A is a sum of basically I and some other matrix. So based on that, we'll try to solve this question now. What has been given to us? We've given us B, which is equals to 7 a to the power 20 minus 20 a to the power 7 plus 2 into identity. So we need to basically find out what our B is, and then we need to find out one of its elements. So simply what we'll do is, of course, in this question also you can solve for, let's say, a square, then you can solve for a to the power 4, and then based on that you can try to identify some pattern and solve this question. However, there is one more way of solving this question. As soon as I look at A, I can see that there is an identity matrix inside A. That means A would have been some matrix which is equals to identity plus, let's say P. P would be the other matrix which we are talking about. So now if I separate these two matrices I and P, what would be nth power of I? Since we know that we had studied here integral powers, I square is equals to I cube is equals to I to the power m is also going to be I. So I power wouldn't be a problem for us. When we look at P, since P would have only values of minus 1 and minus 1, that means there are only two numerical values in the entire matrix. That means if there are, let's say, two or three values only, which are, let's say, numerical values in your matrix, then after certain time, after continuously powering it, after certain time, you are going to get a null matrix. You can look at that. Let me show you it with the example. So A matrix can basically be written as identity matrix, which is 0, 0, 0, 1, 0, plus P matrix. What would your P matrix become? 0 in all the places except for here. Here we would have a minus 1 and here we would have a minus 1. So now whenever, let's say, you have two or less values in your matrix, after a point of time, after powering it up after a few number of times, you would surely get a null matrix. So of course, let us try to find out at what point are we getting it to be 0. So this is my P matrix basically. So what if I find out my P square? My P square would be 0, 0, 0, minus 1, 0, 0, 0, minus 1, 0, multiplied with the same matrix again. So this would basically transform into, here again we would have 0, 0, 0. This would also be 0. This would be 0. Now since we have a minus 1 here, so this would also become 0. This would also become 0 and we would have simply a 1 here. So I found out my P square. Now let me try and find out my p cube. My p cube would basically be 0, 0, 1, 0, 0, 0, 0, 0, 0 into 0, 0, 1, 0, 0, 0. So what would I get my p cube to be? All these values would be 0 here. Here also we would have 0. And here, since there is a 1, let me try and multiply this. So this would become this into this. Again, we would have a 0 here as well. So that means I've found out my p cube is my null matrix basically. So my p cube is nothing but a null matrix. Now since my p cube is null matrix, which means it is 0, that means if I try to find out p to the power 4, it would also be 0. It can be written as p cube into p, where p cube is 0, so it would also become 0. And this would also be equal to p to the power 5, p to the power 6, and so on. Right? I hope you are getting this point. Now that I've found out my p, that after a certain point it becomes 0. Now let me try and solve the equation that the question has given us. What have they told us? That b is equals to 7 times of a to the power 20 minus 20 times of a to the power 7 plus 2 times of identity matrix. So from here, let me first find out a to the power 20. If I talk about a to the power 20, how can I write it down? It can be written as I plus p to the power 20. If this can be written as I plus p to the power 20, and if I use a concept of binomial theorem here, now if you haven't studied the chapter binomial theorem, I would recommend you to first study that. If, as per binomial theorem, if you look at this equation, how can you open this up? This would open up as 20c0 I to the power 20 plus 20c1 I to the power 19 into p plus 20c2 I to the power 18 p square plus 20c3 I to the power 17 p cube, and this would continue on up till we have 20c20 I to the power 0 p to the power 20. Now if you look at this carefully, in all the terms after I have p square, all the terms I would have p cube, then p4, p to the power 5, p to the power 6 up till p to the power 20. And we know all these terms are going to be 0 because my p cube is a null matrix. So all these terms would basically become 0. So I would only be left with 20c0. What is it? 20c0 is 1, and I to the power 20 is simply I. 20c1 can be written as simply 20. I to the power 19 becomes I into P, and I into P. Any two matrices multiplied where one of them is identity. So I would have the second matrix only. So this would become 20P and 20C2. What is the value of 20C2? 20C2 is nothing but 190. Here I would have P square. So this is what I'm getting as a to the power 20. So this is my a to the power 20. Similarly, let me find out my a to the power 7 as well. So it can be written as I plus p whole to the power 7, which can be written as 7c0 I to the power 7 plus 7c1 I to the power 6p plus 7c2 I to the power 5 p square. Now, of course, I hope you all know I'm not writing all this p cube, p to the power 4, p to the power 5, all these terms because they are going to be 0. So what would my a to the power 7 basically become? This would become I plus, here I would have 7p plus 7c2. What is 7c2 going to be? 21 p square. This is what I'm getting as a7. Now let me just simply substitute these values in the position of b and let me find out my answer. So this would become 7 times of 190 p square plus 20p plus I plus, sorry, minus 20 times of 21p square plus 7p plus I plus 2I. Now let me simply just try to solve all this and see what I'm getting. So what would be my coefficient of p square in this entire equation? From here I would have 910 p square, and 20 into 21 is basically 420. So 910 minus 420, 910 minus 420, what is it going to give us? 90, 490 p square. Here we would have 140p. Here also we would have 140p. So this and this would get cancelled out. What would be left with? 7i minus 20i plus 2i. So this would become minus 20i plus 9i. This would become minus 11i. So this is what we are going to get as b. Now let me just try and write down this value. So this would become 0, 0, 0, 0, 0, 0. So from here, what we would get? This would become 490, 0, 0 minus 11 times of identity matrix. So this would become 11, 11, 11, and all the terms are 0. So now what was asked to us in the question? We had to find out b of 1, 3. So b of 1, 3 is basically this value that we are trying to find out, right? So if I find out only my B3, B13, it would become 490 minus 0. So B13 is nothing but 490 minus 0, which is 490. This becomes my answer. Sorry, here this wouldn't be 490. This would become 910. After solving, it would become 910. So here I would have 910. 910 minus 0, and this would become 910. So this becomes my answer. So generally, sometimes in questions, you have to identify the matrix that has been given to you. It might be in some format as identity plus some other some other matrix, and that some other matrix would have, of course, numerical values less than the number of zeros present in the matrix. Based on that, what you can estimate is that after a certain power, that p matrix would become 0. So of course that is what we did here. We could see that there were only two numerical values in our p matrix. That is why after p cube it became null matrix. So that means p cube is 0. So p4, p5, all these values would also be 0. And based on that, we used our binomial theorem to find out our higher powers, and then we solved our question. So keep this method in mind as well.